Good time of day, dear colleagues. Today we'll make our next step in our study of research methods, and we'll talk about quasi-experimental and correlational designs. Today we'll discuss several issues. First of all, we'll take a look at quasi-experiments, and we'll see how do they differ from true experiments, and what kind of quasi-experimental designs are available to us for use in our research. And next, we'll spend quite some time focusing on correlational studies. We'll begin by discussing why are they called correlational at all, and what is correlation. So today we'll start our gentle introduction of quantitative research methods, and then we'll spend some time discussing the strengths and weaknesses of correlational designs, because these are the designs that are most commonly used in science, and we really need to be aware of their limitations. So, to begin with, what are quasi-experiments and why do we really conduct them? The answer is very simple, because sometimes we don't have the resources to conduct true experiments. So, just to remind you a little bit the topic of our last lecture, what is the difference between a true experiment and a quasi-experiment? As we discussed, there are three different types of empirical studies. All of these are empirical studies because we collect some data. But these studies are organized in different ways. In a true experiment, we introduce some manipulation. We manipulate the independent variable. We intervene in some way with the reality that we are scrutinizing. And we control the confounds. In between subject designs, those confounds are individual differences, so we randomly assign individuals to conditions. Within subject designs, those are position effects, so we randomly assign experimental conditions to points in time. If we have this experimental control, we can say that the most nasty, the most awful confounds have been eliminated, and this is called a true experiment. However, sometimes when we introduce some kind of intervention, we don't have the opportunity to control the confounds completely or fully, as we would do in a true experiment. This situation is called quasi-experiment, and we'll talk about it in quite some detail right now. And the third type of study, we'll call it non-experimental empirical study, when we collect some data, but we don't really have any manipulation. We don't manipulate our independent variable. So we are not able to implement the three conditions of causality, all three of them at least. And this can be a correlational study or it can be a longitudinal study, and we'll discuss those studies today as well. So what is incomplete control? As we just said, it's a situation when we don't randomize experimental conditions to individuals or to points in time. Of course, instead of randomization, we can use some other type of control, for example, matching or some kind of counterbalancing, etc. If we use some kind of experimental control to control those confounds, we can call it an experiment. A randomized group experiment or a matched group factorial experiment, if you recall those little labels that Goodman proposed. In a quasi-experiment, there is no control of those confounds. We don't randomly assign individuals to conditions. For example, we are using existing groups. Instead of randomly creating experimental group and a control group, we say, okay, we have those two groups of individuals, so one of them will be experimental, another one will be control. We might have no other choice, and this can be justified. It is only justified in situations when we are unable to conduct a true experimental study. For example, randomization would be too difficult to implement or too costly. It would take too much time, or it would introduce additional influence, additional bias into the setting. For example, if we are conducting an experiment at school, and ideally we would want to create randomly an experimental group and a control group, but if we shuffle children into new classes just for this one particular subject, this would be a completely new situation for them. They would have to meet people they have not yet even met before, and this would introduce a lot of influence. creating new classes itself would be a specific intervention. So if we want to avoid it, our only option is to say, okay, we have class A, class B, and we'll use one of them as an experimental class and another one as a control class. And there are, of course, some situations when other people have conducted true experiments. In this case, conducting a quasi-experiment might not really be a good idea. But if there is limited evidence available, if your study might be one of the first to investigate the issue, then again, using a weaker research design is quite defensible. One tricky point about quasi-experiments that we need to be aware of is that the definitions of quasi-experiments differ somewhat across different textbooks. If you look at the textbook of C.J. Goodwin, which is absolutely great in all respects, but this, I guess, when he says quasi-experiment, he says that basically anything less than true experiment can be called quasi-experimental research. Even correlational research, when we attempt to investigate the effects of some independent variables, even though we don't manipulate them at all, he calls it quasi-experimental. And his logic is that it's not really possible to draw a line between between quasi-experiments and correlational studies. It is a bit difficult, as we'll see right now. Another definition which is proposed by Shadish and Cook, and which I prefer a bit more, is that let's call quasi-experiment a study where there is an intervention, but there is no complete control over potential confounds. So if we attempt some kind of statistical control, at least, we might call it quasi-experiment. The problem is with natural interventions. What are natural interventions? These are the situations when we have some people who have undergone some kind of situation and another group of people who have not undergone this situation. For example, in one region there was an earthquake, and in another region there was no earthquake. So this is a kind of natural intervention, because it's an intervention that happens outside of our control. So Goodwin would call a study which compares people who have undergone this earthquake situation and those who have not, he would call it quasi-experiment. Shadish and Cook would say it's better not to call this quasi-experiment because we don't control this intervention. So if we attempt some kind of statistical control and we try to match individuals from those two groups, maybe we can call it quasi-experiment, but it's better not to. And correlational studies, where there is no intervention absolutely, they definitely should not be called quasi-experiments. So my proposition is to stick to the definition of Shadish and Cook and say that quasi-experiment is a study where there is an intervention, but there is no control over potential confounds, or there is no complete control over potential confounds. And such natural experiments should only be called quasi-experiments if there is some attempt to control confounds. There are some typical quasi-experiments in psychology. For example, the non-randomized between group design, which we have just talked about, where you have two classes at school and you take one of them as an intervention class, another one as a control class. And this is quite common because it is sometimes difficult to form groups randomly. Another common type of quasi-experiment is a within-group design with no randomization, when you have individuals who undergo a series of treatments in a fixed sequence, and you want to compare the effects of those treatments, and you don't control this sequence. So you can publish such studies, you can use them to make some inference, some causal inference even, but the only issue is that you need to be really careful and you need to be aware of the limitations of those studies as a basis for your inference. So if we express it a bit jokingly, you can even publish bad experiments if you call them quasi-experiments and if you reflect really well on the limitations. But of course, this will only work in situations where really good experimental designs are either unfeasible, very difficult to implement, or no one has really attempted them before. Of course, if other people have already conducted true experiments to test the same hypothesis, there is no sense in conducting another quasi-experiment, probably. But of course, reviewers might be optimistic about your study if you're lucky. Don Campbell, who introduced this whole concept of quasi-experiments, he said that instead of trying to conduct perfect studies, we need to aspire to conduct studies that cover the areas neglected by others. And the idea behind quasi-experiment is that actually no study ever is perfect. Every study has its limitations. So as long as you're aware of these limitations, you're totally fine. So right now, let's take a look at some classical designs for imperfect studies, at some quasi-experimental designs.